Just tuning into this unit is going to be good. Help you through it. So if you want a little flippy flappy, this thing, a flag, if you will, those are at your tables. If you want one of those in there for chapter 4. And chapter 4 is all about triangles. Today we're going to be classifying triangles. As we classify triangles, we're going to be using some colors. I'm going to be using red, light green, and light blue, and yellow. So those are the 4 colors I'm going to use. If you'd like to use the same colors, you can. It's going to be really helpful to color coordinate. You could also use highlighters today. So if you'd like to grab highlighters, you can grab highlighters. Those are all sorts of different colors. We're just going to be color coordinating as we work, so that way we can identify those triangles a little bit faster. At the end of today, we are going to play a Blooket. A Blooket. That's what I found out is how you pronounce it. Fun facts. So I would take out your colored pencils or take out 4 different highlighters. Alright, we're going to get started in about 30 more seconds, so get your stuff out, find what you're using. $15 seconds. Five, 4, 3, 2, 1. Alright, here we go. So first off, let's identify what is a triangle. Alright, so we talked about that in our warm-up. A triangle is what? Let's just knew this. What's a triangle? A shape. Can it be open? Like that first shape that we drew? No. So it has to be closed. So we're going to say a closed shape. That has how many sides? That has 3 sides. And how many angles does a triangle have? How many angles? There's 3 sides, 3 angles. If you did not know this, this might be a mind-blowing fact for you today. A triangle. Tri means 3. 3 angles stands for triangle. Whoa. Before you might have been told in your life that tri means 3, so there's 3 sides. It's not wrong. But a triangle literally says 3 angles. No one else is excited about that?
I am. That's one of my favorite fun facts.
Fun fact. Triangle. 3 angles. Alright. Today we're going to classify triangles, and we do it both by their sides and by their angles. So there's 6 different classifications, but when we look at a triangle, it's going to actually have only one classification, but one is going to be from its sides and one's going to be from its angles. Similar to how a lot of you have a first name and a last name, you might go by your first name. My first name's Elise. A lot of my friends call me Elise. But when I'm at school, people call me Miss Morel. I respond to that. Okay? But if somebody says, Elise Morel, I will also respond to that, right? So you kind of have all these classifications. So our first way to classify is by sides. And with our sides, we're really going to be looking at the lengths. We're looking at how long are each of those sides. All right, there are 3 different classifications here, so if you want to try and split your paper kind of into thirds.
So we want 3 parts.
Doesn't need to go down your whole page. We're just going to draw some pictures, show what they mean. All right, our first type of triangle is where all the sides are different. So they're all different lengths. You might have like one short side, one long side, and then one that's a little bit longer too, like that. That's not a good scaling.
When you're drawing this triangle, try to draw it so that your sides are noticeably different. Each of the 3 should be different. You might have to play around with your angles a little bit to get.
So I'm going to color code each of those sides different. So this one, it will be green. And then I'm going to do one side blue. And one side red. So that way I'm seeing that all 3 are different. One way we would know that all 3 are different, rather than just being able to look at it, is if they labeled it and we saw different numbers. Okay, but also if they're all different, will any of them get a congruent symbol? No. So none of them are congruent. We don't have any of those tick marks. So this is called a scalene. Come on, scalene. No.
Now, the words we're going to use to classify these 3 are probably words you haven't used before, you won't really use outside of geometry, they're not going to stick in your brain super easily. So remember that they're on this page in your notes, and when you're working on a practice or you see that word like which triangle is scalene, just come back and look in those notes.
All right, and a scalene means that 3 sides are different. None of them are the same. Alright, so now we know that one option is that all 3 sides are different. What's another option we could have? What? You're right, that's angles though, we're thinking about sides. So think about side lengths. If all 3 sides are different, we could have how many sides that are the same? Cool. That was a hard question. Good job. 2 sides could be the same. Alright, so when we draw this one, we're going to draw 2 sides of the same length. So try and draw 1 and 2. That's not a good one. Miss Morel, struggling today. There we go. Okay, and then we have a longer base there. Okay, if you're not sure which 2 are the same, triangle skills are not up to par today. I'm going to color both of those green, because those are the same. So this side was supposed to be the same as this side here. And that's why we're also writing descriptions in case your pictures are rough. How can I show that those are the same? They're congruent, they're equal, so how do we show that 2 segments are congruent? Yeah, the little line.
Tick marks, yep. Make sure it's the two you color the same color.
Okay, and then we have this one extra side here. I'm just going to color that blue. That's the side that's different. Okay, the side that's different, we're going to call that the base. Even if it's not on the bottom, that one side that's different is the base. The two sides that are the same are called legs. Now these legs are not made for walking. They're just legs of a triangle. Why do we call them legs? I don't know. Okay, so when we have two sides the same, this is called an isosceles triangle. This is a very Greek name. Greeks were obsessed with triangles. Isosceles. Their goal, they thought triangles were perfect. They were the perfect image. So they really liked to visualize triangles. They did a lot of work with triangles in their mathematics back in ancient Greek times. So isosceles is a very Greek word.
One important idea with the isosceles is that idea of which is the base and which are the legs. So if you want to take a moment right now and write a little note to yourself to remind you that the base can move all around, but it's the one that is different. Okay, so it might be on the top, it might be on the side, it might be on the bottom, but it's the one side that is different from the other two is always the base.
So the legs are the same, the base is the one that's different. So our definition of an isosceles triangle is that we have two sides that are equal, or two sides that are the same. Alright, so now we're at the point we have three sides are different, two sides are the same, and one is different. Can anyone think of what is our last combination? All three are the same, yeah. Okay, so our last one is where all three sides are the same. So you're going to try and draw it where all three are about the same. Now, if yours doesn't look like they're the same, how can we show that, in fact, no matter what a drawing looks like, we know for a fact that they are the same? We use those tick marks again, right? This time I'm just going to use 2 tick marks just to show it's a little bit different than the last one. And all three of those sides are equal. So I'm going to color code those all in the same color because all those three sides match. I'm going to use red. If you want to use a different color, that's fine. But all three of these sides are the same. They're all equal to each other. They're all congruent. Alright, now, for this one, it's not necessarily, for this one I don't know, I don't think it's Greek, because we use some bases. I don't know what the bases are, as far as their origin. But this one we call an equilateral. And in an equilateral, there is definitely a base, and there is a prefix. What is the prefix equilateral? Equa, which means equal. And what do you think lateral means? If you move laterally, that means like you're moving to the side. So this is saying that we have equal sides. So that's really what equilateral means, and that just really means three sides are the same. Oop, not three sides same. Three sides same. You're watching that mouse video over there. Alright. That's how we classify by sides. So if it says what type of triangle this is, and you need to know it by sides, Your three options are scalene, isosceles, equilateral. However, we have another way of classifying triangles, and this one a lot of people have been doing for a while, and that's by angles. Now with angles, there are 4 ways to classify triangles. Alright, so our first way is to do a right triangle. And a right triangle means what? 90 degrees. So when you draw that triangle, we like to see that 90 degree, there's like an L shape. And then we create that third side, doesn't matter. We just have that one side that's that right triangle. Or, sorry, one angle, not side. Okay, so we have one angle that's equal to 90 degrees. So we have a right. Another one we have is obtuse. And we've heard that word obtuse before with angles. What does obtuse mean? More than 90, good. So more than 90 would be a bigger angle. And we connect that with that third line. Now, in an obtuse angle, when you look at this, how many of those angles are obtuse? I see this one's obtuse. It's more than 90 here. Is this angle obtuse? No. What about this one? Nope. So how many angles are obtuse? Just one. Okay, so we just have one angle that's obtuse, and obtuse means more than 90. Okay, so if I have right, obtuse, what's the last one going to be? Not last one, the next one. Acute, good. Acute, I have a really tough time drawing acute, if I'm going to be honest with you. It's a really big struggle with me, so I'm going to try and draw this. Acute means that all 3 angles are less than 90 degrees. Kind of acute. What? No, I mean, these are all normal triangles. I think like your normal triangle and my normal triangle might be different. Yeah, that one's acute. Yeah, go for it. I understand what you're saying. As a math teacher, I draw a lot of triangles, so I feel like maybe for you guys, yeah, maybe your normal's acute. I don't know, man. All right, with acute, it has to be all 3 angles are less than 90. So if it's not obvious to you, hopefully they will have it highlighted. This one I'm going to use my yellow because all three is really important. All three angles are less than 90. So even if you see one or two less than 90, that doesn't mean it's acute. It has to be all three are less than 90. Oh my gosh, I'm falling apart. All right, there is one more. This one is technically acute, but we can be a little bit more specific than acute. And this is where all the angles are equal. So we're going to call this equiangular. Equiangular. An equiangular triangle is where all the angles are equal to each other. And we can show that by using our angle marks here. So we can do one, or we could do two lines there, two arcs. But all these angles are the same. When all three angles are the same, we're going to learn tomorrow about why this is, but when all three angles are the same, they should all equal 60 degrees. Okay, so equiangular means all three angles are the same.
And we can see that right in that name, equiangular. If you split it apart, that first prefix is that equa, that means equal, and then angular.
All right, so for that one, what's kind of interesting is with equiangular and equilateral always go together. So if you know you have an equilateral triangle, you can assume it's an equiangular triangle. So these two are always together.
So we could write that as like an if-then statement. If a triangle is equilateral, then it is equiangular. If a triangle is equiangular, then is it equilateral.
Which we call that a biconditional statement. So it goes both ways. Remember that if and only if? I can, yeah. I just didn't know if they could see the always together. Sorry. Working on it. All right, we have one last thing just to add. And then we are going to do our practice, which is a Blukit. Because it's not Blukit. It goes on the website, it's Blukit. Blukit. Silly. Just a little bit. Alright, so when we classify triangles, we classify them both by sides and angles. So we classify both by side and angle. But when we do that, we kind of did it backwards. I don't know why I did it backwards, but I did. Maybe I should have looked at my notes last year and been like, we did it backwards. But when we classify both sides and angles, if I call Miss Seuter by her first and last name, would I say Seuter Amanda, or would I say Amanda Seuter? Amanda Seuter. It'd be weird to say Seuter Amanda, right? But if I said Seuter Amanda, would you all know who I'm talking about? Yeah. So it's really not a big deal if we get them screwed up, but the proper way to say it is we want to say the angle first. So we would say that right, obtuse, acute, equiangular. So we say the angle name first, and then we say the side name. And then we say triangle.
If you notice how when we wrote that as classify both by, and in your brain you want to take a moment right now and switch that around, that'd be a great idea. So you might want to say classify both by angle and side, because the angle comes first, then the side.
Okay. So we would see like an obtuse isosceles triangle, an acute scalene triangle. You guys didn't know there was so much to learn about triangles, did you? They were like, how